Hello, and welcome to episode 133 of The Joy of Coding. My name is Mike Conley. As per usual, going to be hacking on some Firefox stuff today. It's going to be a great time. I'm so glad you're here. Let's take a look at what's going on. Let me switch screens here and pull up the agenda. Hey, okay, so today is March 21st, 2018. Episode 133. A reminder, no plan survives breakfast. I kind of know what I want to do. Well, I don't really know what I want to do today. I didn't really line up much stuff. That's what this bullet is. I was supposed to put things to do today, and I haven't. I never got around to it. So I'm going to be figuring out what we're doing on the fly today. But this agenda that we're looking at, as it develops, and you know, if you're watching this in the future, it's possible that this agenda will have changed and fleshed out with stuff we've done today. This agenda is actually available. It is a thing that you have access to. You can click on the links in. Depending on where you are, it'll be in a different place. So if you're watching this on old Air Mozilla, it's in the additional links section down below. If you're watching this on new Air Mozilla, it's in one of the handout links. I don't know which side of the screen it's on, but it's in the handouts. And if you're watching this on YouTube, it's in the video description. If you're watching this on Facebook Live, it's in one of the pinned comments down below. I think there's only one pinned comment. And if you're watching this on Twitch, then I'm about to drop this link like a fat beat. I'm going to drop this link into the Twitch chat. Boom. There it is. That's the agenda. And for you folks, there's also this link to rate the episode and fill out the form and let me know what you thought. So at the end of this episode, if you want to give me some feedback, every episode has one of these, or almost every episode has one of these rate this episode links, and you can let me know what you thought. And that's available in the agenda and all of the places where I mentioned the agenda is, including for Twitch, which I just dropped into the chat. So you can click on that and let me know what you thought of today's episode after it's done. So where are we? Well, first of all, I want to quickly plug the episode guide. There is an episode guide. If you're not familiar with it, it is a completely viewer-driven episode guide, or almost completely viewer-driven episode guide. And we're up to, I don't think there have been too many pull requests lately. We're up to episode 127, so we're behind by about 5 or 6. If you want to contribute, maybe you have your own notes, or you want to edit some notes, or you want to change some things, maybe some stuff that other viewers might find useful, you can send pull requests to the repository hosting that episode guide to make your changes manifest. I'll merge them in. I will happily merge any notes that you have in. I'm not like looking for spelling correctness. It's just whatever you think would be useful. If you're not sure how to send a pull request, there are instructions in the agenda how to send a pull request to the repository. And I also want to give a quick update on Adzo, which is the tool I'm using. It's a little script I wrote that uses Mozilla Deep Speech to automatically transcribe Joy of Coding episodes. And I realize, someone pointed this out to me, that YouTube just does this. You can do this with YouTube. You can ask it, hey, transcribe the audio for me. And hold on a second, I need to pause Crash Plan. And I'm also going to, hopefully this doesn't break everything. I'm going to switch to wired. I think we're still good. We're still good. All right. YouTube just does this, where it will accept videos, and then if you ask it to, it will do automatic transcription. It's pretty good at it. In fact, it's very good at it. And I believe there's like something like Amara, which I'm about to plug, that allows contributors to edit and revise and correct transcripts. But I didn't want to use YouTube. I wanted to use Mozilla Deep Speech. I wanted to do it myself. So I've been using Adzo, which is my script to wrap Deep Speech, to pull down my videos and to automatically transcribe them. And I've gotten pretty far along. A couple of weeks ago, I made a prediction that today, this episode, they'd be pretty much done. That is almost the case. A bunch of them are done. Up till episode 93 is done. Some of the earlier ones need work. Episodes 94 to 100 are actually a little bit odd, or actually 89 to 100. For some reason, these episodes, all of the transcriptions are out of sync. I have a feeling that's because it's around here. Episode 89 was when? Episode 89 was, just after 2017 when I started to do multicasting. And so I think the multicasting system I used means that the videos up on Air Mozilla are slightly out of sync from the videos on YouTube. And so the transcripts that I'm posting are synced up for the YouTube video or the Air Mozilla videos, but not for the YouTube ones where the transcripts ultimately go. So I'm looking at how to correct that. Probably what will happen is I'll just pull all the videos down from Air Mozilla and re-upload to YouTube to change all these episodes, and you know, that will probably end up being the solution. But if you want to correct or revise or contribute to any of the subtitles here, you can use Amara. Amara is a tool that is great for having a community of people who want to hack on subtitling. Amara.org. You can just create an account and then choose any of the videos that are done inside the spreadsheet, and then you can choose this button here and then say improve these subtitles. Because right now we're looking at English. We're going to improve these subtitles, and you can go in and just start making edits and like shift times and make sure that spelling corrections have occurred. Like some of these are flat out wrong. Things on what do they do, so let's try and find that out. And then day let's see if when give, that's not even a word. So you know, you could find out what that is. Let's listen in and see what it's supposed to be.
Let's try and find that out
today. Let's see if we can find that out today. Let's see if we can, what was it?
What these structures do.
See if we can get a sense. If we can get a sense of what these structures do. Get a sense of what these structures do. And then maybe
what these structures do, and then maybe explore some other parts of the service worker.
Maybe explore some other parts. Of the service worker. I don't know. I'm actually not too happy with the work I just did. I'm not going to save that. I'm actually going to leave. But it gives you an example. You just have to listen carefully and edit the transcripts and then submit them. And that would be a great help. So if you want to help out, that's a thing you can do. And what else did I want to talk about? So that's Adzo. That is auto transcriptions. I talked about the episode guide. Everything is working. I'm recording. I want to quickly plug a show that I do on Fridays with some colleagues here in the Mozilla Toronto office called The Joy of Profiling, where we look at performance profiles for actionable items to make the browser faster. So if that is a thing that interests you, you should check out The Joy of Profiling. We did episode 22 5 days ago. I think we found some interesting things here. Episode 21, we actually found some actionable data. I thought that was quite nice. We had Alexi there as our guest appearance. I normally have Jeff with me, but this time we had an Alexi. Sometimes we get other guests, like here we've got Ted, and down here we had Marcus. Like we get lots of different guests. And if you want to submit a profile for analysis during the Joy of Profiling, here's a link to do that. You just fill in this form to submit a profile for analysis. And if you're not sure how to gather a profile, this link will show you how to do that. Okay, I want to give a quick update on tab warming. So we enabled tab warming last week. Yeah, it was last week it was enabled. It landed. It actually got backed out and then re-landed later in the day of when it got backed out. I think it got backed out on like the Thursday or the Friday, and then it got fixed again on Thursday or Friday. So there's a slight hiccup there where it got turned off and turned back on. But there's some interesting data to look at. So first of all, we have this probe called FX Tab Switch Total E10S MS, which is a probe that measures the time to from clicking on a tab to deciding that we can show the tab, or like to being in the state where we've updated the async tab switcher to show the new tab. And if you look at it up until March 12th, this was remarkably pretty stable. It's hanging around the like low 30s. Well, if we change the date range here, how do I change the date range to include 61? Right around here, this big old drop off here. Maybe I'll make this a bit bigger. This big old drop off right there. This is when tab warming was enabled on the 13th. And holy smokes, we're down to like the low 2s. This little bump is whenever it got disabled again, and then it was re-enabled. And the reason it dropped down is because a lot of the time when we are choosing a link or choosing a tab to click, the layers for that tab are already ready, so that when we do click, it's like an instantaneous switch. We're saying, oh, we know we can just show this tab right away. We don't have to think about it or wait for the layers to be rendered. They're already available. So that's dropped that probe way down, which is, I'd say, a very happy result. The other thing I wanted to point you at is this page. This dashboard shows how many users on Nightly on Windows ever see the tab switch spinner, even if it's really, really short. But if they see it at least once, I consider them an affected client. And for a long time, it's really hard to see because there's these labels all being jammed up here, but around 40, mid 40s, slightly less than half of the users on the Nightly and the Nightly population would see at least one spinner. And that says nothing about how long the spinner was, they just at least saw one. Well, when warming was enabled, that dropped down to mid 30s, which is a great result. And this is again where like this little spike is when it got backed out and it's coming back down again. This is a very nice result for me, which means, you know, fewer people seeing spinners. And this is reinforced by the fact that you can see right here the number of short spinners. These different lines represent buckets where the spinner with the longest amount of time falls into. So all of the spinners that are like under a second, so from the 0 to 909 milliseconds, although this bucket is always empty for some reason the way it's bucketed. You can see this nice drop off here, a spike again here, and then a drop off. It's starting to drop off again. Now you can't exactly trust the very last, the very end, like the last couple of days, because of the way that telemetry is gathered and processed. You usually have to wait for it to stabilize over a couple of days, but this I think is relatively trustworthy right here, and that's great. I'm very happy with that. So the number of spinners has gone down, time to switch tabs has gone down, all of that is good. The other thing that we were dealing with last week was this talus regression on tab paint, and I figured it out, and I want to quickly give you an update on that. The reason that we were regressing on tab paint was because the Moz after paint event that the test relies on wasn't actually firing until the next paint. So we'd switch the tab and we'd show the tab, but then we'd wait until the next paint to say, you know, to stop the stopwatch. And this is because the dock shell for warmed tabs wasn't being activated until after the layers had been received. So now instead of waiting until the layers have shown up to activate the dock shell, if we're not warming the tab that we're switching to, so for example, if the user has used the keyboard or if automation is switching the tab, then we activate the dock shell right away. So only whenever the tab is warming due to some warming interaction, like hovering the tab or closing a tab, which will warm the next tab to look at, only then will we wait until the layers are available to activate the dock shell. And actually that makes me think of something. Using tab switcher, set tab. I've been getting this error a lot. Sublime linter is not happy, and I haven't looked into it yet. Yeah, we'll maybe activate the dock shell. That's what it is. We maybe activate the dock shell if the tab is the requested tab. Yeah. Okay. So that solved that problem. If we can look at the graph now of the tab paint test, and we can see how it's evolved over time. So here's the graph. Let's look at Linux. So here's where it regressed, very clear regression. Here's where we got backed out, and then after the back out, I landed again, but the regression didn't recur. So tab warming is enabled, but there is no regression there, which is very nice. So that's all good. what are we going to now work on today? That is the question. And let's try and figure something out here. One thing that we can do related to tab warming, it has to do with another telemetry probe. So we have this probe called tab warming state. FX tab switch request tab warming state. And what it does is it records at the time of the tab switch whether or not the tab that we're switching to was warming or not warmed or fully warmed or couldn't have been warmed, so that we know, over time, if we increase the number of places where we can warm the tabs, we should see the number of not warm tabs presumably go down, is the hope, or eventually like stabilize and converge to some point. And there's this really weird thing where the probe made sense until late February, right around here where loaded just hit the floor. Now loaded is always 0%, which makes no sense because loaded means that the tab is fully warmed and ready to switch to immediately, which is often the case, is more often the case than not. And it made sense over here where just slightly over 50% of tabs were warmed and ready to roll, and now it's 0. That makes no sense, which means that the probe is broken. So there is a bug filed, telemetry. There's this bug filed. Tab warming telemetry on warming state of tab seems to be pretty wrong. And this is this is something that Chris Hutton, Chris HC Chutton brought to my attention, and I'd like to fix it. So maybe we can look at that today. So let's see if we can reproduce the problem. First of all, what's my working directory at? Okay, that's fine. So let's warm some tabs. So I'm gonna switch tabs a bit, switching tabs, open another tab. I'm gonna open that tab in the background, warm it, click on it, open that tab, warm it, click on it, open this tab which can't be warmed. Oh, about add-ons, yeah. About add-ons can't be warmed because it's an in-process tab. Example.com. Right. So we've got some telemetry now. We should have gathered some telemetry, and we can take a look in about telemetry to see our warming state. And lo and behold, there are a bunch of things in the 0 bucket. And if I remember correctly, the 0 bucket means what does that mean? Let's take a look. Zero means disqualified. So the tab couldn't be warmed, which is, if you look at the graph, yeah, that kind of matches what we're seeing coming in from our nightly user population as well, where nearly just over 70% of the probes report that the tab switches are disqualified, which is bunk. Totally bunk. So let's see how this probe works and see what's going wrong. So the way the tab, the way the probe works is here. Whenever the user is actually clicking on a tab, when the user asks to switch to a given tab, we check to see if warming is enabled, and if so, we default to being disqualified, and then we look to see whether. Okay, here's where one of the problems is already. If can warm tab, not warmed, not warmed. Okay. If this can warm tab, it has can warm tab. State is loaded, loading or loaded, return false. Okay, so here's what's going wrong. when we do this calculation, we're looking at this thing, the warming tab set. And the warming tab set is a weak set of, I believe it's a weak set. Warming tabs is a weak set of tabs that have been asked to warm up. And in order not to, this is used only for telemetry and logging. In order not to overcomplicate the async tabs further, has nothing to do with how warm tabs are loaded and unloaded. Interesting. And I think I may have broken that. I think we've broken that assumption that warming tabs is just about telemetry, because we use it here to say that if we're warming a tab, then we can load it, and we can try loading it. And we remove things from the warming tab set right here in unwarmed tab. An unwarmed tab happens whenever the layers for the tab become ready. That's the problem. Okay, so here's what's going wrong. We have the set of tabs, and warming tabs really should have warming tabs should have a different name. Warming tabs should be warmed tab, or no, warming tabs is the right name, but I think this is using warming tabs incorrectly, or at least warming tabs has changed such that it can no longer be used the way that it wants to. So warming tabs only has a tab if it's in the process of being warmed, but as soon as it's warmed up and the layers are ready, it's removed from this set. And it'll be in state loading, meaning that this warming tabs will not have the tab if the tab is warm when we click on it, and we'll realize that, like, we'll evaluate that we cannot warm the tab because it's already loaded, so that the tab will be marked as disqualified. That is the problem. So let me quickly write that down. Let me put start a note up in active bugs. The problem here is that this .warming tabs doesn't have the tab, the warmed tab in it after warming has completed and the layers are ready. This is likely fallout from the last bug I fixed before we enabled tab warming, which was rendering error after scroll. That's a new one. Should look at that too. Short tab spinners. This is likely fallout from, because in this bug, what did I do? I made it so that we use warming tabs, the warming tab set. I evicted the tab from the warming tab set here as opposed to here. So what are we going to do? This is likely fallout from this bug where now warming tabs is used to determine whether or not we can switch to a state loading tab or not. Okay. And that happens here. Okay. So here's first idea. First idea. Or ideas. Create a new weak set called warmed tabs, where after tabs in warming tabs have entered state loaded, they're taken out warming tabs and put into warmed tabs. Then, as soon as they're either evicted or requested, they're removed from that set. That's one idea. What's another idea? Can we somehow infer that a tab that we requested we can just look at the state of tabs as we request them to see if they're in state unloaded, state loading, state loaded, or state unloading. Request tab. That might actually be better. I'm not super keen on this, simply because it adds more complication. We have to have these two sets. We have to keep like both of them warming and warmed in mind. This seems like it's more overhead. This, when we request a tab, knowing whether or not it's in state unloaded, state loading, state loaded, or state unloading. Is that as useful? Yeah, because as we become more effective at warming, more things should be in state loaded. And what are the not warm, still loading, loaded? How would this work? So what we do is start by defaulting to disqualified and then seeing whether or not the tab is in state loading or state loaded. So the problem with one is that it adds extra overhead and management for yet another weak set. The problem with two is that it means we sometimes capture data about tabs that were never warmed in the first place. It's a little less precise. Is that okay? So what are the cases? What if we request a tab that's not warmed? That might actually be useful information. If we know that we've requested a tab that is like unloading, and how often that occurs, that might be useful. Hmm. Can warm tab. The other problem with 2 is that we have to account for tabs being requested that never could have been warmed, like parent process tabs, like about add-ons, about robots, etc. Okay. Interesting. Oh, wow, there's some traffic in the Twitch chat. Let me just quickly address it. Hey, first time on our stream. Your bio is empty, so I'll ask, what are the themes in your Joy of Coding series? This is from Stitch RSA. And DWL Salmeda says, the links on Watch People Code always mention hack on Firefox. And yeah, that's in reference to the Watch People Code subreddit, which is where I tend to post my links. Yeah, so I am working on the Firefox web browser right now. And in particular, I'm looking at the code that switches tabs with multi-process Firefox. And I'm trying to make it so that the telemetry we gather on the performance of tab switching is accurate, because right now it's not accurate. So hopefully that answers your question. Stitch RSA. Okay. The other problem is we have to account for tabs being requested that never could have been warmed. So what do we do about that? How bad is the overhead from 1? Get I mean, as a variation on 1, we could also turn the weak set into a weak map, mapping a tab to a warming state. But that also feels like a lot, because we've already got the loading state, state loaded, state loading, state unloading, state unloaded. And if we add yet more state, whether we're warming or not warmed, like you're not warmed, you're warming, or you're warm, all warmed up, not warmable, that feels like a lot. It's a lot more complication. I'm starting to center in on 2. When in doubt, go with the simpler one. And this, I think, is simpler. It's just that it will slightly be contaminated if we're not careful. It'll be contaminated with information about tabs that could never have been warmed. Well, I guess in this case, if tab can warm tab, what does it do? It makes sure that the tab is not answered, closed, not remote, crashed, already visible, already requested. Warming up this tab makes no sense. So we can look at can warm tab first. Right? There's can warm, and then there's maybe there's should warm. Can warm tab. Can warm tab. Because there's difference between whether or not you can do something, whether you should do something. Maybe that's the simplest, is if I abstract can and should warm tab is true if we can warm tab, return this dot can warm tab and, or if this dot can warm tab, then let's state equals this. If state equals state this or this. So if you can warm the tab and state equals, there are only two other states. State is unloading, state equals state unloading, or state equals unloaded, return true. Otherwise, return false. That should warm the tab. That should be roughly equivalent. If the tabs that are already in state loading or state loaded have no need to be warmed up. Okay, and then down here we get rid of this check, and this can warm tab is now slightly different. So I'm going to change this warm up tab to use should warm tab, and now this one use of can warm tab we can actually do this. If this dot can warm tab let warming state equals disqualified, or maybe, yeah, I'll do it like this. If tab warming is enabled, if can warm tab, so basically copying the structure from before, but if we can warm the tab, then we look at the state. Can warm the tab, then we need to take a look at the state. And if the state is loading, still loading, loaded, else if tab state equals state unloading, or tab state equals state unloaded. Warming state equals not warmed. Right? If we can warm the tab, even though then we're still loading, or we're loaded, we're not warmed, or disqualified. I think that'll work. And then we add that state to the telemetry. We can probably clean this up a bit. But let's see what happens when we build that. So let's okay, so immediately we get a bunch of background tabs here, and there shouldn't be anything starting in warming. Now these background tabs, we can't actually warm them because they are technically not actually loaded. They're these lazy tabs in the background that load when you click on them. So I should get a disqualified here. Disqualified. Oh, tab switch isn't even working. Something's gone wrong. Reference state unloading is not defined. Okay, so I screwed up a little bit here. Yeah, I have to refer to an actual item here. So let's build again. Stitch RSA says thanks, and I say you're welcome. Let me play you a sound, Stitch RSA. This one's for you.
Oh, yeah.
Okay, so if we switch to this background tab, we should have gotten a disqualified, and then this one should be warmed, warmed, disqualified. So 2 disqualifieds, 2 warms is what we should get. And I think that's what we got. Let's look at histograms. Disqualified is actually 0. We got not warmed and 0, 1, 2, and loaded. Not warmed. So that's not. Can warm tab. Should warm tab. All right, well, we're logging in the background here, so we can repeat the experiment, this time with this about new tab back here. This should not be warmable. So that should not have been warmable. Yeah, disqualified. Same. Okay, so maybe it was working properly, and so we should have gotten a couple of disqualifieds there. And 1, again, what's 1? Not warmed. Some of them are not warmed. Some of them are loaded. 8 were loaded. 8 were not loaded. Or 8 were, yeah, not loaded, and 6 were disqualified. Now if I just kind of like switch around a little bit, most of them are loaded. Which makes sense. But disqualified keeps going up. I guess disqualified is these 2. Yeah, these 2 are disqualified. And when does not warmed go up? Does not warmed go up? Let's restart again. Repeat the experiment. Interesting. Tabs that are lazy, we go not warmed. Which is strange because I would have expected them to be disqualified. Oh, but the time that by the time that I request them, they're probably inserted. That's what's going on. Gotcha. So like not warmed. Stay unloaded. Request the tab. By the time we request the tab, wait a second, is that true? Wait a second. Let's add a debugger here. Let's add a debugger here and restart the experiment. I think my assumption's wrong. So, let's choose this tab. Huh, not hitting my debugger. Did I not build? I don't think I did. Okay. Okay, here's our breakpoint. So the requested tab, does it have a linked panel? It does. By the time I requested it, it got a linked panel. Linked browser. It was just inserted. When does that occur? Select new tab. Selected item. Selected index. Request tab. When is the tab inserted? I guess what I'll do then is I will set another breakpoint inside tab browser.js, insert browser. Right there. Insert browser, it's on, mouse down, select new tab here. Setter, selected index. And we get the related element. And that happens just before, I think before we request the tab, right here. Right. Okay. So this plan might not be amazing. We can warm this tab but this tab never had a chance to be warmed. Never had a chance because it was just inserted before we requested it. I don't think there's a way we can know that. Maybe that was always a problem. What is the current code? If we go back, take a look at what the current code does. You request the tab. Yeah, I think this was always a problem. This was always a problem. And newly inserted browsers, just so I know, there's no way of knowing that they've just been inserted this tick, right? ID. Tab browser inserted. Well, this event is fired on the tab. So you could what could you do? No, this was always a problem. I think I'm actually okay with that, just so long as we spell it out. So at this point, lazy tabs, lazily inserted browsers have already been inserted into the DOM. A lazily inserted, at this point, if the tabs browser was being inserted lazily, we never had a chance to warm it up. And unfortunately, there's no great way to detect that case. We'll end up putting this in the not warmed bucket. Those cases will end up in the not warmed bucket. Perhaps my reviewer will have an idea here. Okay. All right, I think that will do as a patch. Maybe we can clean this up a little bit here with a switch statement instead. Switch tab state case this dot state loading. This is the sort of thing that Rust's matchers are way better at. Loaded. I think I'm missing a colon there. Break, and then case this dot state unloading. Case this dot state unloaded. Through warming state equals not warmed. Is that better? I don't know if that's better. I don't think that adds anything. I think that just adds a switch statement. Alright, never mind. This is probably just as readable. Maybe I'll put this comment in here. Along with legitimate cases where tabs could have been warmed but weren't. If the tabs browser is being inserted lazily, we never had a chance to warm it up, and unfortunately there's no great way to detect that case. His will end up in the not warmed bucket along with the legitimate case where tabs could have been warmed but weren't. Okay, I think that's pretty clear. Right, let us take a look at the patch. Stitch RSA says, I have to go now, but I will definitely check out your previous videos in the series. Keep up the good work. Thank you, Stitch RSA. Have yourself a safe journey wherever it is you're going, where you're heading off to. Okay, so some of this is actually not necessary. There's some old stuff here from a previous experiment I was working on that I think I can undo under, I think, DOM. Yeah, revert DOM IPC. And then there's another change over here in use dump for logging. I was logging and I don't have to make that false. hgdiff. I'm also going to get rid of, well, here's what we can do actually. We can do hgcommit interactive. What's this? Line 852. Should warm tab. Okay. It's just a weird diff thing. Yeah, I see. If not, should warm tab. Can warm tab. And then this I don't want. Let's change to logging. So this is bug such and such. Fix tab warming state telemetry. Tab warming state probe. Let's have Doug Thayer look at it. This, as of, I should also probably, hang on, there's another thing I want to do. So I'm going to revert the stuff that I didn't want to commit, and I also want to change this comment up here. So hold on, let's ask to warm up. So holds onto the set of tabs we've been asked to warm up. And tabs are evicted once they're done loading, or once they're done loading or are unloaded. Okay, that's what I wanted to do. DWL Salmedo asks, can we have a quick recap after this? Sure, we can try. I can try. I'll do my best. Let me, first of all, update the commit message, and I'll try and do a quick recap. Since bug. The warming tabs weak set has been cleared, has had warmed tabs cleared from it once once they have entered state loaded. Tabs has had warmed tabs cleared from once they have entered state loaded. This allowed us to make decisions on tab switch operations based on whether or not a tab was in the process of was still being warmed. This broke our telemetry, which assumed that warming tabs would still be in the warming tabs weak set until either requested or evicted. Now instead we look to see whether or not tab warming is enabled and whether tabs could have been warmed in order to populate the right buckets, or to add entries to the right buckets. Okay, let's take a look at the patch again. Okay, and let's push to review and take a look at it again in the diff viewer, and then I will do a quick recap, and then I'll probably end the episode. My throat's a little bit hoarse. I wish I had a hoarse sound.
What happened?
I don't have a hoarse sound, but I should have a hoarse sound. So we'll push this up for review, take a quick peek at the diff, make sure it makes sense before requesting review. Go. Okay, let's look at the diff. Okay, this is a practice I like to do, self-review. Before I publish a review request, I like to do a self-review. I think it's a pretty good idea. It's worked for me because my brain goes into a different mode when I'm reviewing patches, and when I'm using this tool, I go into reviewing mode. So yeah, we've made it so that can warm tab is true if makes a tab could be warmed, and then whether or not we should warm it is based on whether we can and if the tab is not already loading or loaded. No need to be warmed up. Can, should. Else if tab state equals state unloading or tab state equals state unloaded. All right, let's see what Doug thinks of this. And then I will recap while writing the recap and the bug. So the problem here was introduced in bug such and such. So just to recap for the people, DWL, Salameda, and others who want to recap, this is the problem. This is our FX tab switch request tab warming state probe that's running on nightly, and it looks to see whether or not tabs that we switch to are in the warmed state, which means that they can be switched to quickly because we started to preload and pre-paint their contents when you hover them. And before the end of February, it was actually, the probe data made sense. It was right around here at the end of February. There was a big inversion. The number of tabs that were warmed up and fully painted dropped right to the floor and was 0. The number that were disqualified shot right through the ceiling. And I wanted to figure out what that was because that's inaccurate. And we can't make decent decisions on inaccurate data. So the problem was, and I'm going to write this in here. So the problem was introduced in bug 1432509. What happened was that the warming tabs weak set was originally used as a holding area for tabs that had been warmed but not requested yet, and they were removed from that set when requested or when evicted after the unload timeout. Bug 1432509, the telemetry probe, depended on that, so that at request time, tab time, before removing the warmed tab from the set, weak set, it could say whether it could check state, the tab's state, and then determine whether or not the warmed tab was fully loaded or not, or had even been warmed in the first place. Bug such and such changed all of that by making the warming tabs weak set hold warmed tabs until their layers are ready, after which they are no longer warming but warmed. So then after layers are ready, so that meant that at request tab time, if the tab was in state loaded because it had fully warmed, request tab would think that the tab had never been warmed in the first place. And then what would have happened? Let's look at the old code. And then it would fail both of the conditions. Would think the tab had never been warmed in the first place. And also isn't in a fit state to be warmed since it's already loaded. So it'd fall back into the disqualified bucket, which is just nonsense. So I've broken can warm tab into can warm tab and should warm tab. Can warm tab returns true if the tab could potentially be warmed, and should warm tab is used to determine whether or not it makes sense to actually warm the tab. It's a subtle distinction, but it means that it's maybe a subtle distinction, but it means that we can use can warm tab when determining in request tab which buckets to put the requested tab. If it can be warmed and is in state loaded, then chances are it was warmed. If it can be warmed and it's in state loading, chances are it was warming but didn't complete, etc. It's not perfect. This will catch tabs that were never warmed but could have been. Oh man, maybe that is a bug. Actually, now that I think about it. What happens if we can warm but we're not warming because we're using the keyboard, for example? So this might be a problem with my approach. So we're not warming when we use keyboard. And what do you think about that? One means not warmed. Which is valid, because you could have been warmed, but you weren't because we were using the keyboard. This is an opportunity to warm. That's not a bug. I think that's fine. It's not perfect. This will catch tabs that never had a chance to be warmed. For example, lazily inserted browsers after a session restore. However, I also considered having another weak set called warmed tabs, where after tabs entered state loaded, or after warming tabs, they'd get moved to that set, weak set, and we could use that instead for telemetry. It just seemed like too much complication, but I'm open to revisiting the idea. What do you think, Doug? Okay. So I'm assigning that to myself. I'm going to make this a fx perf p1 because that's my team, and p1 means you're working on it. And I think that's it. Hopefully that was a decent enough recap, DWL Salmeda. And I think I'm going to cap it there. So let me close this down. And switch to here. Hey, thank you so much for watching episode 133 of The Joy of Coding. Hopefully that was interesting. We figured out what was going on there with the probe, I think. We did a couple of... I came up with a couple of different ideas for solutions. I picked one. I feel like I can justify the choice, although I'm open to argument, which is always the case whenever you're working on software, because it's a team sport. So I'm waiting to hear back to see what my reviewer thinks, and keep an eye on this bug if you're curious. Just for the folks who want to follow along, maybe I will put the link to the... Hang on, I'll switch back to my screen so you can see what I'm doing. I'm going to put the link to the bug in the agenda so that if you want to go back and refer to it, you can, and I'll put a link to the notes here as well. Boom. Boom. Done and save. Hey, that's it. And also, if you want, like, I implore you, let me know what you think of the series and let me know what you think of this episode. You can click on this link here to rate this episode. It's in the agenda. It's in all the places where the agenda is. All those links sections. Rate the episode. Let me know what you thought. I snuck a picture of myself going like in the end of the form. If you want to check that out as like an added incentive, we'll see. I'm checking to see if that increases people's filling out the form. We'll see. I read every entry that comes in, every response, and I use it to help make the stream better. So let me know. And with that, I am actually going to call it. So thank you again so much for watching episode 133. I will see you next week. Take care. Bye-bye. See ya.